All right, gang, welcome. So what we're going to do today is cover the details of a Crayford Focuser, how it works, what are these components, what are these screws used for, how do we disassemble it, how do we maintain it, if this thing's got a lot of play in it, what can we do to fix that, and what we're also going to cover is the installation. Set the box over here. Installation of ZWO AEF, Electronic Automatic Focuser. So this is my second one. I've got it on an 8-inch Astrograph, and I'm about to put it on a 16-inch Dobsonian. So why am I doing this? One, if it's information that I've kind of figured out through trial and error, I'm sharing it with others. We should always be in the business of, sharing knowledge that we have, and at the same time, we should always be in the business of learning. But the other reason is before I installed it on the first scope, which is over there, I've got it under a little dust cover. I'm not going to uncover it. I did a little Google search to try to find, how am I going to do this and how does this thing work? I want to know what's inside here before I start popping screws off and digging into here. And even better, if I could find detailed instructions on how to install the AEF, that would be nice. And I didn't find a thing. Now, the little manual that comes with it is a little bit disappointing in that you would think a company like ZWO, as much as they sell and as sophisticated as their electronics are, you'd think they'd have a much more detailed instruction manual. It's got some pictures in there that talks about basic installation. They have no mention that I can tell of a Crayford Focuser. It's all a helical style focuser, for example, for a refractor. And even then, it looks as if they built the pictures full scale and then shrunk them into an instruction booklet that literally is about 4 inches square. So even if those instructions did apply to a Crayford Focuser on a Newtonian scope, you wouldn't be able to read them anyway, because the details are lost and you wouldn't be able to understand really what's going on in the pictures because they shrunk it down so low. So with that being said, in fact, I've got it sitting over here, matter of fact. And so there's I assume it's Japanese, there's English, you find. So there's a parts list, and here you go. That's it. I'm missing them to Newtonian, and that's all they've got. So, and it's really not that helpful anyway. So that's what we're going to go through today. So the first part of this, and by the way, I apologize up front because I've got to hold the camera, mess around with this focuser, do some point outs here, and all of that requires 3 hands. And guess what? I've only got 2. So let's talk about what this focuser is and how it works. Well, this is a standard Crayford Focuser, 2-speed, in that I have a coarse adjustment knob right here, and you can see the focusing tube, focusing tube going up and down, but there's a fine adjustment here too as well. This is an 11-to-1 ratio, and most of them out there, that's the standard ratio, meaning for every 1 turn of the coarse, I get 11 turns of the fine, or I could take the reciprocal of that. 11 turns of this requires 1 turn of this, or 1 turn of this is 1/11th of this, but you get the picture. So hey, let's get the thing about in the ballpark, right about there, and then we'll fine tune it with this right here. And of course, this is the one that we would make adjustments with based on temperature, and maybe, when you're going from Jupiter to Saturn for some planetary, you'd make some minor adjustments there too as well. So that's what that is. Right there. Let's talk about these screws right here, because this is important. Oh, by the way, let's cover this first though. The focuser itself, I have a focuser assembly. Okay, it's mounted to a focus, what I call the base plate, and the base plate is secured to the OTA. It doesn't move, it's not adjustable, it's secured to the OTA. But the focuser assembly is attached to the attached to the base plate through this screw, and there's 2 more over here, and it forms a triangle. One here. Again, I'm pointing this out and holding the phone and looking through the screen, and one here. So the focuser assembly is attached to the focuser base plate through these 3 screws. But check this out. I can back those screws out as I've done here to create a gap, which would mean there's a little bit of play in there, but then there's a set screw that I can tighten up to lock it in place. Much like when you collimate your main mirror, there's a knob to move the mirror back and forth, but once I get it set where I want it, there's another screw to lock it in place, and that's what this Allen head screw, set screw right here does. And for each of these base plate screws, remember there's 3 of them, one here, and one here, there is a locking set screw. I found during collimation of this scope not too long ago that I had a little bit of tilt on my focuser assembly, and I took that tilt out by making this adjustment right here, and that's what that is. All right, so with that being said, now let's go to these screws. Let's see if I can get something here, if this is better to point this out here. This is gonna be weird. Okay, so I'm gonna hold the camera here and go through each of these. This, it's obvious what this is, right? That locks the focuser tube in place. If I back this out some, I can rotate this knob, and of course it moves the focuser. But if I tighten this up, rotating the focuser knob doesn't do anything. It keeps the tube in place. I think we've all done this, right? Where I have focus set for a particular camera, let's say a planetary camera, but then I have to use my illuminated reticle to recenter the planet in my optical train, if you will, and it looks out of focus, right? When I look through this this illuminated reticle, and it's what natural for us to grab the focuser knob and make the picture look good. So I go, okay, let me focus this. Now let me center it. Okay, good. Then I put my planetary camera back on, and guess what? It's not in focus. So this locks it in place. Also, if I'm changing, let's say eyepieces, obviously you're going to change focus, but maybe you don't want this thing to settle too much, and or to bump at all. And what I like is I can accidentally turn it and it won't move, or if I bump it, it should lock it in place too as well. Now let's talk about this for a second. If I back this out, now there's no friction. In fact, it's loose in there. Oh, and by the way, I won't, well, I'll go ahead, I'll back it out in a minute, but this is the type that has a little rubber or plastic or nylon tip on it so we don't scratch the focuser tube. But now with this unlocked, watch what happens if I put a little pressure on this tube. See how it slides in, and yet the knobs aren't turning? My technique is, and I think one should have, it's set up this way so that in the event this gets bumped for whatever reason, it doesn't put a lot of stress and strain on the focuser mechanism itself. It's got a little bit give to it right there, okay? A little bit of give to it. So let's talk about now, let's continue on with the rest of these screws. So with that being said, let's back this guy out now. So that's your friction knob. Come on. This is going to be a somewhat tedious and arduous video, but like I talked about, there's the nylon tip on there. Let me set it over here. So let's talk about these other screws. So this is the hole that we just pulled the friction knob out of, okay? These four hold, these four right here, so your four corners hold this whole assembly to the focuser body. This shaft here, or whatever you want to call it, this casing and this bracket and then that casing, that's all one piece. And these knobs and all the mechanism stuff in between the knobs, it gives you the 11:1 ratio. It's like a planetary gear mechanism. And this whole plate come off, and it's held in place with these four screws right there. Okay, so that's what those four are for. Let's talk about this bottom one. That is completely useless. It does nothing. There's a set screw in there, obviously, and we'll talk about what it's for and what we do with it here in a minute. But it is essentially, we don't use it for anything, bottom line, yet. And I'll show you why here in a little bit. So let's talk about now this center screw, okay? There is a rod that runs from knob to knob, so it runs through this bracket assembly, and you're going to see it here in a second when I take this apart. That rod rotates when I turn these focusing knobs, and that rod rotates up against this flat part. Let's get a good angle here. This flat part of the focusing tube, and it's the friction between this rod that's right here and the tube that causes this thing to go up and down. Okay, this Allen screw here, this set screw, It's really weird to look through the screen and hold an item and try to point stuff out. This right here, when I tighten this up, when I go clockwise, it pushes that rod tighter against that. So watch what happens if I back this out. Let me back this out about a 3/4 of a turn or so. Now I'm going to press this, but man, it watches it almost, in fact, it will fall in on its own. And I've had this scope about 4 years, and I've had to make an adjustment here. And the reason why I knew I needed to is because I'd put a heavier eyepiece on here or a camera, and the thing would slide in on its own. And of course, any adjustments here do nothing. Well, I say do nothing. You see, it's trying, but there's just not enough friction there. So if we take this set screw and tighten it back, now we've got friction between the rod and the flat part of this focus tube, and now it'll work. And I should still have a little bit of free play here, so if I press that, if I press this down and it doesn't want to budge at all, then we want to back that out just a little bit. Okay, so that is those screws. Now let's talk about these two right here. Okay, this rod, and I'll show you here in a second, is floating on what I call a Teflon plate that's held in place by a metal bracket, and that metal bracket is secured with these two screws here. So these two screws here do not go all the way through the bracket assembly into the focuser body. Okay, they're internal to this only. So when we take this thing off, we do not need to take any of these off. Remember, only the 4 that hold this thing on. And there's some little washers under here too, so be careful when you back this off. All right, back those out. So I'm going to take off this bracket assembly by undoing these 4 screws only, and I'll come back to you here in a second. All right, folks, welcome back, and we have this bracket assembly now removed. And I would recommend, obviously, that you have a flat working space just to neatly set out everything, all the parts and everything that you need. And in addition, anytime there's stuff that can roll away, I usually use a piece of foam. So yes, this is nice to have, but this stuff can roll off if this table is bumped. So I tend to put everything there. Also, anytime I disassemble something, I arrange the screws to reassemble it back kind of in the same pattern. So remember, I had 4 screws I removed from the 4 corners, so I've got 4 screws right there. If I were to remove these as well, then I would arrange them relative to one another. So here's the bracket that we were talking about earlier. I'm trying to find a place where the lighting's good. You can see we removed those 4 screws, so that's why you've got the 4 holes in the 4 corners. And then down here at the bottom, we've got that hole there, and that's where the focuser tube friction knob was at. And then of course this one here that I said was basically useless in a way is still there, and then these are still there. Now let's look at the inside of this thing. Here is that kind of a Teflon bearing. It's like a triangular or curved shaped bearing, and all this does is, remember, we want this metal rod to press tightly up against our focuser tube, and that's where that occurs, right in there along that flat area like I showed you earlier. And I need it pressing up against there enough, or hard enough, to create friction to do its job. Okay, now why wouldn't I want to use just a I don't know, a tooth gear or something like that? I'm not an engineer, so I don't know the term. Well, there's a couple reasons I imagine. One is that you're going to have backlash, and if you're familiar with mounts, you know what that term means. You'd have a little bit of focuser backlash. You have some anyway, but now it would be even worse. And by the way, with a toothed gear assembly here, if this gets bumped or knocked into, there is no giving, and all the stress is absorbed by this bracket assembly and by the base and by your upper OTA. There's no give here. Whereas the flat surface against a smooth surface rod, functioning by friction only, I've got a little bit of leeway there. But in the event there's not enough friction, what I do is I need to press this rod up against the focusing tube a little bit tighter, and I do that by adjusting this right here, and that's what we did earlier. Remember, I gave it a little bit of a turn, and that's kind of a that's how that works. Now this assembly is flat, so it's got to kind of have a flat plate to rest on, and you can see that it's resting there. Let me back this out a little bit because it gives you the illusion that there's contact there, and there's not at all. So let me just back this out some. There you go, backing out the kind of so-called useless set screw. Now let's come back here and look. Well, there's still a third screw there, but it's coming from that middle one. Let's see if we can look at it this way. Yeah, still looks the same. So what are those 3 posts or screws in there? Well, it's, come on, baby, cooperate with me. It's these 3 right here. So this is the one that presses the rod up against the focusing tube, and then these 2 hold this bracket in place and provide it some balance. So imagine, you know, we want this Teflon bearing, we don't want it tilted one way or another. We want it to be, the stress of this rod to be equally supported across the whole surface of the bearing, so we don't get premature wear and the thing functions correctly. So we do that by setting this bracket parallel with this bracket assembly. And how do I know they're parallel? Well, I just look at the gap. I hold it up to the sky or to a light or this white table, and I make sure that they're parallel. In fact, it looks like it may be slightly off there. But how would we adjust that? Simply by these screws right here. That's all that you're doing there. And when you take this off, you almost don't need to do anything with these right here at all. You don't need to do anything with these right here. So the other thing I wanted to show you is, remember when this thing was on here, oh, by the way, while we're here, let's look at this. Here is the gap in the focuser body where the friction knob goes through. Here's our friction knob. It goes through here. So that useless set screw I talked about, it just presses up against right there. And someone's tightened it enough to actually kind of gouge the aluminum here, but it really doesn't do anything, because if our 4 screws are tightened and has that whole assembly plate up against the body, then this thing doesn't do anything. There's no need to have to tilt this or adjust it or anything like that. So that's basically useless in a way, but in a way it's not, and I'll show you here in just a minute. So back to what I was talking about earlier on this focuser assembly here. Remember, it was arranged like this. If I can kind of just trial fit that on there. It was arranged like that. Notice the fine knob is towards the back end of the scope. Well, when I do my planetary, I'm actually, relative to the scope, I'm standing like this because I have a table right here. That's why I extended the hand controller cord, because it's all the way over here on this table. In fact, it's right here. I've got wheels on it and it rolls around with my scope, and whenever my scope slews to a different position, I can roll the table easily. But I can't do all that, and by the way, I got the laptop there and all, but I can't do all that from back here. I want to, because I can't get to the camera if I got the table here, right? So I do everything right here, which means to find focus, I have to reach back over here and do this, or come across the top, and there's cables and it's just an awkward position. So I prefer it to have the fine focus knob over here. The point of all that is, even if you don't have an automatic focuser and you're not installing one, and you just want to change the position of the fine knob to this side, and again I'm having to film and do all this with one hand, to this side, I hope I don't drop it, to this side, it's easy to do. All you do is pop this off, flip it 180 degrees, take that useless set screw, move it down here, that opens up that hole, and now that hole becomes what? The hole that you use for the friction knob. It's that simple. We don't have to make any adjustments to these other ones. We put it back on, we put our 4 mounting screws back in, adjust that middle one as required if need be to get the friction needed to do what we talked about with the focuser tube, and then you're done. So even if you're not installing automatic focuser, this could still be helpful. While we're here, by the way, let's take a look at this. This thing will completely come out just like so, and you can see how they've machined down that flat side. In fact, you can tell the part of that flat side that rod makes contact with are the edges right there where it's darkened. So if you ever have you've tightened that friction screw quite a bit and you still don't have the friction you need to make this work, pop this out and just clean that off right there, and that could help you. Looking down inside the tube, you're going to have 4 bearings. So you got one back in the back, one here, one there, one here, and the tube itself is pressed against the back of the assembly, so it rolls, if you will, it slides on these 4 bearings, as well as the rod that we talked about. And by the way, I'm sure there's formal terms for all of these, I just don't know what they are, so I'm calling them kind of what they make sense to me. If I'm wrong, somebody can correct me in the comments, but quite frankly it won't make a difference. But anyway, this really slides up and down neatly, smooth. So anyway, I'm going to leave that there for now. So back to our bracket assembly, or knob assembly, whatever you want to call it. Again, we've shown that we don't have to make any adjustments or any changes to these, maybe to that one in the end to increase the friction if we need to, but we shouldn't. And I really won't go into that plate. These screws just slide through the hole. In other words, the hole isn't threaded for this screw, okay? But the plate is threaded to accept that screw. So for example, let's see if I can do this freehand. So if I back this out some right here, I back that out some, loosen it just a little bit, you'll see these screws now. See how there's a little bit of play in there now? In fact, if I press one, you'll see the other one move. If I press this, you'll see that one move. Watch this. If I press this one, you'll see the other one move. Why? Because it's kind of like a teeter-totter effect. So now here's the plate, and watch this. See that? So if I tighten this thing back up, so now I'm pressing the Teflon bearing up against the rod a little more tighter. Let's see. No, let's try another one. I've got like 4 Allen wrenches here. There we go. So tighten that up just, I'm not going to crank on it hard. Just tighten it. Now you'll see there's no play in these. Why? Because they're now tightened, and the Teflon bearing, whatever you want to call it, is now flush up against here. But look at that plate. It looks to me like the right side is a little higher than the left. In other words, they're not parallel, and that's really what you want to have there. So what I'm going to do is I'm going to back this out. It's much like collimating your secondary mirror on a Newtonian. You have to tighten one screw, you got to loosen the other. So we want to tighten this one up a little bit to make that balance. I'm going to have to back this out just a little bit. And if we're going to tighten that side, we have to loosen that side a little bit. Remember, it's a teeter-totter, right? So if one side of the seesaw wants to go down, the other side has to go up. So I loosen that up a little bit. Now I'm going to tighten this one up just a hair. Maybe a quarter of a turn. Now let's tighten this back and see what we got. It's, again, like collimation, it's kind of a trial and error. Let's see what we got here. That looks pretty good. Maybe now the right side's a little lower, so let me back that off. Probably killing you all with boredom. So I'm going to back that off just a tad. Get the right Allen wrench in here. Yeah, that's just the camera. I'm going to back that out just a little bit, which means I have to tighten this one up equal amount. Now let's take a look at it. I'm happy with that. Okay, so that is your Crayford Focuser, how it operates, how if we want to, let me adjust my camera here, if I want to, I can swap ends over here and put the fine focus knob on the other side of the focuser for whatever reason you would want to do that. And And that's it. So that's how it works. And then the assembly is just the reverse opposite of what we did. All right, folks, so now we're going to talk about installing or attaching the ZWO Focuser. So I've got it right here. I didn't do a box opening, but I'll just kind of talk about what's in there. You're going to have some various screws and whatnot, and some washers. The most of this I found useless for the Crayford, I'll be honest with you. And as we go through, I'll tell you why when we get going here. And again, I think they mostly sent stuff for a helical type of focuser. You're going to have this bracket, and this bracket's going to go on here like so. So it's going to go on there, and then of course your focusing mechanism, motor and whatnot's going to go right there. So I'll show you how to do that here in a minute. I recommend, okay, back, I found what I was looking for. So back to what I was talking about. Here's what comes with, here's the screws and whatnot. These little things are couplers, so they will attach, they are used to attach the shaft of the focusing motor to the shaft of your knob bracket here, your focuser bracket, whatever you want to call it. And really what it is, it's just a really, really tough, kind of a spring, if you will. What this does is it allows you to mount this focuser with the output shaft not exactly lined up with, I'm sure there's an engineering term for that, with the shaft of your focuser. In fact, it allows you to have a little bit of play. The other thing is, as well, in fact, you can give it a little bit of a squeeze here. You can kind of see what I'm talking about. The other thing this allows you to do is, you know, it's just a sensitive piece of equipment, and if there's any kind of binding or, you know, once this is attached, somebody comes up and bumps this, or you out of habit go to grab the knob and try to adjust it and want to turn it harder. Somebody does it and doesn't know that you can't do that with a focuser attached. This thing will allow a little bit of play. It's a little bit forgiving, so it takes some of the stress off of the focusing motor. Now, this thing is going to attach this bracket. Again, this is going to be challenging. There we go, if I can do that. This thing is going to attach kind of like that. Okay, so we're going to attach using the 4 corner screws as well as a 5th one in there, and I'll show that to you here in a minute. The problem is the 4 corner screws that came with your Crayford that we used to disassemble, remember there's our 4 corner screws, the ones that went in here, are not long enough to reach through here, and then go into the threads into the focuser assembly. Just, they're not long enough. So go to your local hardware store and get these, okay? The specification, it's metric, and the specifications are M3 0.5 by 16. And there's your spec, 16 millimeters long. I know that's what that means. So, and here they are right here. Now here's the other interesting thing. When you go buy these things, the heads of these screws are too small for the washers that they supplied. This is another disappointment. Washer, you know, if you buy them in mass, you know, mass quantities, what are they? 1/10 of a penny? I don't know. But ZWO could have done a better job in providing a wider variety of washers. So you're going to have to get your own, and I did. These are maybe even a little bit slightly too big, but you want to make sure that the head of the screw won't go through the inner diameter of the washer. So go get these 4 things before you start this project, and then you're not going to sit around with your focuser disassembled. So the focuser itself, the focus motor, is going to attach to the coarse end of this rod. Okay, so let's talk about how we're going to take that off, and it's real simple. If you take this bracket assembly, you'll see some holes in here. You get a couple right there. In fact, there's a set screw, there's a hole. But on the coarse end, remember that's the fine end with a coarse knob, and this is the coarse end only. On the coarse end, you're going to have a hole. I'm going to set the camera down with 2 hands. I'm going to show you something. So here we go. You're looking down that hole. Now you see that shiny thing down in that hole? That's this shaft right here, running right through here. I take that back. This is a machined piece of aluminum, and it's got a shaft, it's just all one piece, that goes all the way through this bracket assembly here, and that's what you're looking at, so my apologies. So you see that shiny thing? Well, you're seeing this aluminum here, but watch what happens if I hold the bracket and rotate this coarse knob. Here we go. Just slowly while I'm looking down there. Oh, it got dark. Keep turning. Oh, got shiny again. Dark, shiny again. So what that is it's a hole with a set screw in it. So I'm going to turn it so that it appears at least that the hole down inside there is aligned with the hole right here. And I'm going to pop an Allen wrench in there. Just like so. Yep, it fits, and I'm going to give it just a slight turn. Remember, we're not backing this set screw all the way out, just maybe a quarter of a turn. Now watch this. Boom. And that's it. That's what you're looking at. There's that set screw. See how it's partially raised out now? I don't like that. I've moved a lot in my life, and when I left stuff like that, just the vibrations of your stuff going down the highway in a moving truck will back screws out, believe it or not, and you'll open the door to unload and find things have fallen apart on you. So I like to screw that thing back in, and I'm going to set that aside, and again I'm going to set it on my working foam here, just kind of off to the side. And now we got our bracket here, our focusing tube bracket. Now we're going to trial fit this real quick just to see what this looks like. So there's our focusing motor. Here are two tapped holes, threaded holes for this to go on, just like so. Okay. And let me make sure that this is going to go like that. All right. So something like that, and then this will go on there like that. So kind of along those lines. And you can see how the shaft of the focusing motor and the shaft of my knob assembly bracket, whatever you want to call it, are aligned. Okay. So the next step is we're going to attach this aluminum bracket to our focusing bracket. Now something to look at here. If you look at this thing, look right there. See how it's kind of got these ridges, which mean if this is laying on a flat surface, you're going to have a gap there, and you need that because remember, these screws here do not move. These are not going to move, but they are not countersunk or even flush, so they're raised above. So that is what this gap right there is for. So you have to make sure you put this ridge side, whatever term you want to use, up against here like that, so that those screw heads clear. Okay. So again, let's just look at this. We know the focusing motor is going to go on this side. This is a challenge here. We know the focusing motor is going to go on this side, which means we have to have our fine knob on the opposite side, right? And it makes sense. So let's just kind of do a trial fit here. And by the way, remember we talked about this useless set screw? Remember, this is the way it was with our friction knob in that hole. Now that so-called useless set screw is there, but now that we're going to turn this upside down, guess what? I don't know why this thing isn't going to focus. Now that useless set screw can be moved. I don't know why I'm out of focus. That useless set screw can be moved from here down to here, and that frees open that hole to put our friction knob into. So I'm going to swap those real quick, or swap that set screw position, and I'll come back. All right, folks, back with you, and all I did was take this so-called useless set screw that, remember, this was like this, and it was here, and I moved it there, and since we're going to flip this over, I moved it from here down here because remember, our friction knob is going to go up here. And that reminds me, let me show you something real quick. The end state here is going to have the focuser here, and then the fine/coarse knob combination on this end. Now, I'm bringing this up because your scope and how you use it and how you transport it may dictate what side of the focuser assembly you have your automatic focuser. I'm choosing this side because it's going to extend. Again, I've got another one installed over there, but I'm not going to take that cover off. It's going to extend to about right here. So if I had it on this side, it would extend probably right to the edge of my OTA. Plus I got cables coming out. And I don't like stuff hanging over the lip of my scope. Furthermore, I actually take this apart and transport it fairly frequently to dark sky sites. Notice my finder scope, and by the way, the bottom of the upper OTA, this is a truss tube knob. Notice it's here, but my finder scope extends past that. So when I take this upper OTA and move it, I can't set it down right side up because it'll hit this, right? Whatever surface I'm setting it on, like the back of my SUV, will hit this. So I put it in my SUV. I put it in my SUV upside down so that this flat flush surface supports the weight of this, and then I just cover the backside with another big lens cap. And that way I don't have anything, you know, bumping up against the ground or whatever surface I'm setting this on. And I didn't mean ground, you know, I'm talking about the back of my SUV. But if my focuser was like this, well, now I have something extended beyond the front and beyond the back. So how am I going to transport this thing? I'd have to set it on edge. Now I got to worry about it rolling around, bumping into the focuser assembly or into the finder scope, etc. So I want everything to extend on this side so that I can easily transport it. Furthermore, remember I talked to you, a lot of my imaging, when I'm near the scope, when I'm doing DSOs, I set it up and walk away and I go watch a movie, right? But if I'm doing planetary, I'm there almost the whole time. And I'm not on this side of the scope. Well, this is where all the cables are going to come from the camera, the power cord for the focuser on the old version. This one uses the USB 2.0 power supply, the 5 volt. But I also have, you got the temperature cord or the handheld controller. And I don't want the cables coming on this side where I'm standing. I want them over here coming away from me. So it just makes sense to put the focuser motor over here. So with that being said, let's put this sucker on here. So it's going to go like that. It's going to go like that. I'm just doing another quick review here. And then there's our two holes. I just got a glimpse of my nugget there. And so those holes are going to go inside these two slots. This is funny, man, this is where an assistant comes in handy. Man, you got to respect those people that make movies. So you see those holes there line up in those slots, and we'll adjust those as required so that the shaft of the focuser assembly lines up with the shaft of the focus motor. So we know then that this is how this goes. So now we're going to take one of our screws with the washer, and we're going to feed it through here. We're just going to do one right now, and you see how it's got a little bit of reach through, which is good. That's what we need. We're going to grab the correct Allen wrench, and now we're going to go over, and I am going to take this just with one screw only and attach this to that focuser assembly. And I'm not going to crank down on this screw yet. I want to get all four in there, figure out where this bracket needs to go, and then I'll come back to you. But obviously it would be mundane for you to watch this, and it would be impossible for me to do this and hold a camera at the same time. So I'm going to set this down, do it, and come back to you. All right, gang, bracket assembly now attached. I told you, I think I may have mentioned, the washers I have, or I think are a little bit, the inner diameter is a little bit too large for the heads of these screws right here, and that one washer just won't stay. So I went ahead and tightened it enough to secure it. But when I'm done making this video, I'm going to go to the local hardware store. I'm going to get a set of washers whose inner diameter is much smaller than what I currently have. But I at least wanted to do that right now. It's secure, good to go. If I were to turn the focusing knob, you'll see the focuser to go up and down. Not sure what that glitch was. Up and down. If I press on here with a little bit of pressure, it slides, but to me it takes a little bit too much pressure. So like we talked about, I'm going to get my Allen screw, and we still have access to these middle screws right here. So I'm just going to back that out, man, about a 1/16 of a turn, if even that. Now let's give it a test here. Yep, got some slide. I'm going to do it just a little bit more. Back that up just a little bit more. That was probably a 30 seconds of a turn. Now let's see. Yep, I like that. And in fact, I'm going to go back in a little bit. It was a little more loose than what I want. Bam, right there. And I'm going to just leave it there. So you got your fine knob. It still works fine, no pun intended. And then your coarse knob, and all this still works as advertised. But we have the shaft right here, and this is what our focuser is going to attach to. So here's our focus motor, and those two holes right there are going to line up with these two slots right there, just like so. And then our shaft, two shafts are going to line up just like so. So now we need the coupler, which is that spring type device that I showed you, that's going to attach these two shafts together. If you look at all of these, depending upon what kind of focuser you use, if you pull each of these out, and I'm not going to do that because I don't want to bother putting back in, but if you pull each of these out, you'll find that one end has a drilled hole, and so both ends have a drilled hole, but you'll find that one end is a different diameter than the other, and the larger diameter is for your, well, it depends. You're going to have to figure out which end you want to put on the focuser and which end you want, the focus motor, and which end you want to put on the shaft. For this one here, notice I got a smaller diameter. It won't even go on here. It doesn't even fit. But this larger drilled end will. So you want to make sure that you can see how that goes on there. And of course, then that end's going to go on the focuser knob shaft that we talked about earlier. Now, the shaft diameter in your focuser may be different than mine, and you may end up using one of these. See how that one's even bigger than that one? And they come over here and it's still small size. Why? Because they know that these, no matter which one you pick, one end is always going to go on here and the other end's going to go on your focuser shaft. And so that's why they've made these with different diameters. So for what we're going to do here, and there's different ways to do this. We could have put the focusing motor on here first, then attach the bracket to the focuser assembly. But I like doing it this way because I don't want to fight with this with the weight of that on there. And heaven forbid if I drop this while I'm fighting with that, this is all that hits the ground versus the whole assembly. So now this coupler is going to go on here, just like so. And you can see, I'm going to have to swap hands here, pardon me. You can see how this can go all the way up inside there like that. I just want it just enough to where I know that set screw is going to bite and grab on to that shaft right there. I don't want this thing, it will fit all the way up in there. Well, I say it will. It's not going to now because I've got the Allen screws all the way down there. But it will, and I don't want it all the way up in there because it sometimes on the other one I've installed and this one when I did a test install, it rubbed up against here a little bit. So I'm going to put that up there and then I'm going to back it out just enough to have a little bit of a gap right there. And then I'm going to tighten that Allen screw and that Allen screw and put this sucker in place. So I'll be right back. All right, shaft coupler installed, and if I turn this, you'll obviously see that turn, and you'll see in there I've got a little bit of a gap. Again, like I said, this whole thing can slide up in there and fit inside there fine, but I didn't want to do that. I don't want to risk any kind of rubbing, and although it may not be hurting anything, you're going to hear it, and hearing something like that will drive me nuts. So now the next step is to put the focus motor on here. Now, how we're going to do that, before we do the screws here, we're just going to attach the shaft here. And it'll be dangling by the shaft, that's okay. And then we'll do these screws right here. So this shaft of the focus motor has a flat side to it. Hopefully you can see that. Yeah, there we go. See how it's got that flat side to it? So that flat side we want to be lined up at least with one of these Allen screws. So here's the flat side, here's an Allen screw. We want that Allen screw to be set against, really it's called a set screw, set against the flat side. There's two of them here. Here's one, here's the other one. So either one of these will work. So I'm going to rotate this so I can put the focuser right there so I can get to it. That Allen screw is, that set screw is tightened in right now. That's why I can't get the shaft in there. But when I back that out, I'll be able to put this in there and then tighten that up. So let me do that real quick. All right, there you have it. So I rotated the focus motor body so that the flat part of the shaft coming out of the focus motor was lined up with that set screw. And then I tightened it. Now I'm just gonna, and by the way, how far up in here did I slide that? All the way until the focus motor body made contact with the bracket. And there's actually a little bit of play right there, so we're going to make an adjustment here in just a minute to fix that. But that's really what I did. I slid it all the way up in there. And in fact, what I can do is, yeah, so here's what we're going to do. I can get to that Allen, that set screw right there. That's the one we just attached the golly, man, it's hard to point stuff out. I just set that, tightened it up. But notice I have a little bit of a play right here, which is fine. That coupler can handle it, but why have it if you don't need it? But guess what? We can get to that set screw right through here. So I'm going to loosen that set screw, push the focus motor body further forward so that it's definitely up against this bracket, retighten that set screw, and then come back and tighten this one completely, and then we should have this properly positioned. So I will come back. All right, so the focus motor body is now attached to the coupler via the shaft and these two set screws. I loosened that one, slid it forward, now it's all the way up against the bracket. And now, and by the way, it's hanging by the shaft on there, that's fine. As long as we're not pulling on anything, it's just sitting there on its own weight. Plus this coupler, like I said, it's a spring, so it's got a little bit spring action right there, that's fine. So now we're gonna rotate the focus motor body until those pre-drilled holes, these tapped holes, that you see right there just line up with the slots, just like so. And then we're going to get our two screws and washers supplied by ZWO that came with it, and we're going to use these two to secure the focus motor body to that bracket. And I'm going to do that and come right back. All right, focus motor now attached to the focus motor bracket, which in turn is attached to the focuser body, and everything's good to go. So what I'm going to do here now is I'm going to connect it to my laptop and just test that it works and all. By the way, notice this isn't going to turn now. There'll be a little bit of play in it, what we call backlash. You can see that. And there's steps online, and even the ZWO driver or app that they have online to drive this. I use ASCOM. We'll show you how to take that backlash out or how to compensate for it. But this is what we have here, and you can see a little bit of play in that coupler when I try to turn it, and that's what that coupler is for, to take that out. The question then becomes, do I need the friction piece there? Well, notice this will still slide. I mean, I can force it to slide a little bit. So yeah, you're still going to need that, because once we set focus, this focus tube can still be bumped, or you put a heavy camera in it and that thing can move. So we're going to replace that, and guess what? It doesn't even go in there. So we'd have to slide this. So what I'm going to do then is loosen these up a little bit. I'm going to loosen the Allen screws that hold that shaft, and I'm going to slide the bracket. I'm not going to take the motor off the bracket. I'm going to slide the motor and the bracket together slightly forward enough to give me a gap to put the friction knob in there. See, this machined hole here isn't lined up with the hole for this friction knob. So that's all I'm going to do, is just slide that up a little bit that way. But let me get the laptop, connect this, we'll do a quick test, and then we'll be done. All right, so I got the focuser hand controller connected through the jack in the back here. Obviously, you can look online and see where that's at. I got a USB 2 cord connected to my laptop over there, and that's it. This newer version does not have a power cord. There is no 12-volt DC input like on the older one. I went ahead and took the cover off this scope right here to show you this one. This is one I installed a while back, and by the way, I use these screws right here instead of the 4 right here. There's a reason for it, but I'm going to go back and do these 4. But if you look on here, you've got 12 volt. This is for your hand controller or the temperature probe, not both. You can only use one or the other. And then obviously a USB 2 port here. But the difference is that 12 volts. You don't need it now on the newer ones. And I've got it, plugged in right there. So if we just simply go, and in fact I'm actually processing some planetary imagery now. If we go to the ASCOM app, well, it says it's running already, so there we go. So ASCOM's up and running. Some people call it ASCOM, tomato, Caribbean. So that's its current position, and we can just click here and it's moving. So we know it's working and it's connecting. Also, any software that you have that can control a focuser, like SharpCap, for example, Sequence Generator Pro, all of those can control this focuser disconnected. But now, and I'm sorry about the lighting, so now I'm in the fast mode here, and I can turn it. And of course, if I go to fine and turn it, you're barely even going to see it move. You're going to see it move over time, but to see it instantaneously move. And of course, it's reporting back its position, and it'll reflect here on the screen. So there you have it, folks. I hope this was useful. I know it was a bit painful probably to watch, a bit lengthy, but I wanted to cover all the details, cover all the things that I had to figure out and that weren't necessarily online. And there's your the workings of a Crayford 2-speed focuser, as well as the installation of a ZWO AEF. Talk to you all later. If you've got questions, comments, I encourage them, leave them below. And if you like this, if it was the least bit helpful, click subscribe. Furthermore, I got a lot of other videos on here about some things I've done with regards to astronomy and some other projects. So take care.